Hello, welcome back to our lecture series. In today's class, I'm going to start relative motion. Now, this is something which many people feel difficult. You can keep watching. I'll try to make it as simple as possible for you people, and then as I said, you go through the video, and if you have any queries or comments, please put it, and don't forget to subscribe the video. Okay, and if you like it, of course do like it, but do subscribe. Right now, coming back, say for example, a body A, its position with respect to some fixed coordinate. I'll call it as any frame P with from this point to this point. I'll call it as position of A with respect to this fixed frame. I take another frame, this one, I may call it as P dash. This may be moving, right? Let this be B. Now, what is the position of B at this instant with respect to this fixed one? We will call it as RB. RB is with respect to fixed position. RA is also with respect to fixed position. Now, what is position of A with respect to B? I'll draw this and put the arrow. Position of A with respect to B. That is B, the second letter that I am giving, with respect to that you have to see. Okay? So, this is RA. Now, from usual vector triangle, the addition is these two are in order. Therefore, RB plus RAB is equal to RA bar. It's purely by triangle rule of vector addition. Now, how do I get RAB now? RAB is RA minus RB. So, this is what we call as position of A with respect to B. This is relative position. So, that is nothing but RA bar minus RB bar. This RA bar is with respect to some fixed point. RB bar is also with respect to some other fixed point. Now, supposing if I differentiate this with respect to time, I take d by dt of all this. Suppose if I do, this is nothing but velocity of A with respect to B. This is nothing but velocity of A bar minus velocity of B bar. By same analogy, I can also give you, if I do it at again, I can also write A bar minus AB bar. Just go through those things. Right. Now, this is the fundamental definition of relative motion. Right? Now, whenever some data are given in vector notation, always if you get directly, there is no problem. Direct subtraction you can do. Otherwise, split that into ij components and do the same procedure as you are doing here. You understand my point? Say, I'll give you an example. Here is a bus moving with a certain velocity v. There is a car which is moving with a velocity c. We will call it as Vc bar and Ub bar for you to understand that these are the velocities of car and velocity of the bus. If I want to know what is the velocity of bus with respect to car, how do I do that? Velocity of bus, what is that? Ub bar minus velocity of car, what is that? Vc bar. Likewise, you have to, suppose if somebody wants to know Vcb bar, what do you mean by this? Velocity of car with respect to bus, that is Vc bar minus Ub bar, U for bus, B for bus and C for car. Likewise, if you, whether it is straight line or anything, you can do it this way. Say for example, if both are moving in the same direction, say bus is moving with 60 kmph, car is moving in the same direction with so I want to know what is velocity of car with respect to bus. Remember, velocity of car with respect to bus. What do you do? Velocity of car, Vc bar, velocity of bus, Vb bar. Incidentally, both are in the same direction. Let us take it as plus sign. This is also plus sign. Therefore, what do you write here? Velocity of car is 80I minus 60I, right? And that value is 20I. In the same direction, car has a velocity moving with a velocity of 20 kilometers per hour relative to the bus. I hope this point is clear to you. Now, I am erasing this part. If you want to know what is velocity of the bus with respect to car, I want you to write this every time to avoid confusion. Here you can say because it is very easy, you can very happily give the answer, but do not forget the fundamentals. When you write the fundamentals correctly, you will never go wrong. So, what is VBC? I am putting it. So, VB bar, that is 60I minus 80I minus 20I. What do you mean by this? Velocity of the bus with respect to car. If car were to be at rest, with what velocity bus would be moving? Minus 20I. So if car were to be at rest, bus is moving backwards with 20 kilometers per hour. In the previous case, we see V, then velocity with, if you are in the bus, you will observe that car is coming towards you with 20 kilometers per hour. Is this point clear to you? Fair, simple case, very easily you can do. Now supposing this is going like this with 60 kilometers per hour, this is going here with 80 kilometers per hour. So I again want to know what is the velocity of the car minus velocity of the bus. Velocity of the car 80I minus, what is this? Minus 60I. Be careful here. Now this is where people go wrong in relative motion. If you are comfortable with this, everything is clear. But remember, never ever try to imagine yourself in the car or bus and then how it is going, because it is along a straight line. You can very easily say But once it is two-dimensional, it is very complicated. Do not try to imagine, do blindly and interpret the answer. What is this, okay? 140i. This is how along the same straight line, if they are moving, that is how you have to give it. Is that okay? Now, what do I do? This is along a straight line. Now, if this is I, let this be J. Now, car is moving along. The bus is moving like this. Or rather, I would say, bus is moving like this along J. It is 60, 80. Never give 80 minus 60 or 80 plus 60. It's absolutely wrong. Every time you work out how it is to be given, then only you will get. I want to know what is velocity of the car with respect to the bus. Bus is stationary, or bus, you are observing everything from the bus. That's the meaning of it. So VC bar minus VB bar. What is VC bar? 80i minus what is this? 60j. This is I, this is J. Therefore, there is nothing that you can do here. So, what is the magnitude of this? You have to work out separately. 80 square plus 60 square. You got this? 100 units. And at what angle? Minus 60 by 80 alpha with respect to I. You may give alpha with respect to J also. Relative velocity is to be worked out in this fashion. If they are perpendicular to each other, you have seen. If they are along the same direction or opposite direction, we have seen. Now we look at an inclined case where this is moving at an angle theta like this, right? Now this 60 velocity vector, you have to resolve into I and J components. So this is 60 cos theta, this is 60 sin theta. Therefore, velocity of the bus is 60 cos theta I plus 60 sin theta J. This is clear to you? Right. Now, how do you work it out? So, as before, I want to know VC bar. VC minus VB bar. What is VC? 80i minus 60 cos theta I minus 60 sin theta j. So, this is nothing but I plus j, that is minus j, remember, minus j 60 sin theta. If you want to get the magnitude, you can get it. This square plus this square, you will get 80 square plus 60 square. You can in fact use this as a very generalized formula. I want you to take a note of it clearly. Hope you have noted down. Right. In this example, these examples I gave you direct absolute values. Suppose if relative velocity is given, now I say VAB is 60J. VB is 40I. What is VA? That means relative velocity is given. Velocity of B is given. What is velocity of A? Very simple. This is VAB is equal to VA bar minus VB He is asking VA, therefore VAB bar plus VB bar. What is VAB? 60J. What is VB? 40I. That's all you have to do. You write this as 40I plus 60J. So work out the modulus. Oh, sorry, he is asking B. So how do you get under root 40 square plus 60 square? That is the magnitude. And then with I, what angle does it make? Tan inverse. I am not simplifying it. I want you to know how to get this all with respect to I. So whether it's a kind of jugglery. Always look whether velocity absolute is given or velocity relative is given. Based on that, you can easily find out whatever that is asked for. Now I'll give you a practical example. Here is some cart moving like this, say with some 80 units, and here is a person. He is throwing the ball vertically up with 40 units, same units. Now, there is a ground-based observer. He is fixed. How does this body look like to him? How does this body look like to him? Now, we have to look at that. How you will get it? First of all, let us do this as Ij. I'll call this cart as A, ball as B. So what is the velocity of the ball with respect to A is vertically up. That is 40J. And what is the velocity of A bar? 80I. This is nothing but VB bar minus VA bar. And you want VB bar. How do you get it? VBA plus VA. Now substitute. What is VBA? 40J. What is VA? 80I plus 40J. And then if they ask you what angle with horizontal it appears, tan inverse 40 by 80. Likewise, you have to work out, right? So, to him, it appears in a plane. So, remember, for him it is a straight line, but for him it is a parabola that you will understand later on. Okay? Is this clear to you now? Okay. Now, next model I'll give you is, see, relative velocity, however great way a book discusses, this is always confusing. So don't go deep into it. Number one, don't try to interpret deep into this. Do the problems blindly with the concept given. Okay? Now, for example, if I take an incline, let this angle be beta. Suppose if this is fixed, then if I drop a body, let me say this is a smooth incline. If it is a smooth incline, how does the body move? The body simply moves and reaches the foot of the incline, right? Now what I do, at any one instant, let the position be like this and let its velocity be v, so that if this is I and this is j and this is beta, means this will be beta. So v cos beta along I and v sin beta along j. This is the velocity when you resolve it into components. Okay? This is a fixed inclined surface. I'm not getting into any detailed problems here. Fundamentals only I am dealing with. Now, if I go to a smooth, this is also smooth. That means as the body moves, this is pulled like this. So we will not get into this dynamic complications here. But what I do, let me take this as velocity of the incline. And let this be velocity of the block. Now, what is VBA? What do you mean by VBA? Velocity of the block with respect to incline. Now you may get a doubt here. I'll show you very clearly. For example, this is the initial position of the inclined block. Okay? As this moves down, this is pushed back. So probably this is where the body might have come. Look, body is here, next position is, next position may be here. It's a very, very complicated when I am observing it from the ground, or I am fixed. I am observing this. So what is that velocity? Supposing if I say, how does the path of this body look like with respect to the incline? Always remember, whenever they say with respect to the incline, treat that incline as fixed, as though incline is fixed. As though incline is fixed. Then how does it move? It will move parallel to the incline. Therefore, relative velocity or relative acceleration of this body with respect to the incline is always along the incline. Now, this is an important statement. Velocity or acceleration of block B with respect to incline is always along the inclined surface with respect to ground. Motion is complicated. We will find out what is that complication. Okay? I hope you have noted down. This is a very important point I am writing here. Just because it is drawn here, don't take that as velocity of the block. Velocity of the block with respect to incline only should be taken along the inclined surface. Right? Now, if that is the case, VBA is like this. As before, we will take I. See, generally J should be above, but this IJ by convention, we can deviate whenever we wish. Okay? It's not going to make any difference to the understanding of the problem. Therefore, I want to write velocity of the inclined bar. How is this moving? Minus IVI, because it is in this direction. This is plus I, this is minus I. What about this? I told you, this, if this is beta, this is beta. Therefore, this is VB cos beta and this is VB sin beta. How do you write velocity of the block with respect to incline? A or I, anything. So, I, V, B, cos beta plus J VB sine beta. And what is this? VB minus VI. What do you want VB? How do I get? VB bar is equal to VI bar plus VBI. So what is VI? Got it. Minus IVI. And what is VB? I VB cos beta plus J VB sine. You can combine these two and write it here as VB is equal to I VB cos beta minus VI plus J VB sine beta. Alright? You got it now? Yeah. This is what? This is how the body appears to move with respect to any ground-based observer. What is the magnitude? Now the rest, of course, you need not have to tell you. Some of the squares you will get. And as before, alpha with horizontal is tan inverse VB sine beta by VB cos beta minus V. See, don't get carried away with the complexity of these expressions. Just work out by simply resolving them into components. See whether relative velocity is given or absolute is given. They'll simply ask you like this. The relative velocity given, they'll ask absolute velocity. If they give absolute velocity, they will ask relative velocity. Okay? This is how you have to work out. Is this clear to you? Now, we'll have to go one by one. Now, let us look at a simple case of a person. The bus is moving likewise, and somebody from behind is trying to catch the bus. Suppose the bus is moving with 40 kmph and he is moving with 60 kmph. Initial distance between them is say 10 kilometers. When does he catch the bus? This is the question. What you have to see, what is the initial relative position? Initial relative position or bus with respect to man is 10 kilometers. Final position, when they meet it is 0. So the relative position or the relative displacement is 10 km. 10 minus 0. They may say what time it takes for this to become 2 kilometer difference. So you will put 10 minus 2. What is the time it takes for them to become 3 kilometer apart? 10 minus 3. They meet 0. 10 minus 0. Okay. And what is the relative velocity? Man, position of the bus, yeah. What is the velocity of the man with respect to bus? I think it is better to take like this to avoid any confusion. Velocity of the man with respect to bus. Both are in the same direction, therefore I am taking it. So what is the relative acceleration? Because neither of the two things is accelerating here. Therefore, AR is equal to 0. What time he catches the bus? So how do you work out now? Simple. Just as because he is a uniform relative velocity, so this is uniform motion. Therefore, directly you can find out t is equal to s by v, that is 10 by 20, that is half an hour. So in half an hour he is going to catch the bus. Now look at this AR, why I kept it as 0. Now supposing, this is the first problem. Second case is, he is not moving with 60, he starts with 0 but accelerates at, I will give you this in meter per second to avoid all the complications. Let me say this is moving with 15 meter per second, and let me say this is accelerating with 3 meter per second square. So A is 3 meter. Now, of course, initial distance, therefore, SR is always 10 kilometers. What is the initial relative velocity? UR 15 minus 0, 0. And what is the relative acceleration? This is 3, this is 0, 3. You got the point? Right. Now, I want to know what is the time. And when they get it, what is the time means, what do? All are constant values. A constant, therefore, V is equal to U plus AT. S is UT plus half AT square. U half AT square. So 10 is equal to half. AR is 3. This is T square. So you have got T is equal to 20 by 3. That means he will catch the bus at exactly T is equal to 20 by 3 under root. Likewise, you have to understand. Okay? Now, sometimes they'll ask you, a small train is going, let me say, with 20 meter per second. This train is going with 40 meter per second, and this distance is 100 kilometers. They are moving in the same direction. This is moving much faster than this, and this train doesn't know that this is coming. To avoid accident, what is the minimum acceleration this train has to apply? To avoid accident, what is the minimum acceleration? Acceleration means if they ask A, you will get negative value. If they ask what is the minimum retardation, you will get positive value, right? So let us say what is the initial relative velocity, same direction, therefore 40 minus 20 meter per second. And SR is 100 into 100 kilometers into 10 raised to 3 meters. Now, what is, let us say AR is equal to A. Okay? Now, what do you mean by avoiding accident? This will move, this will move. At one stage, they will move in such a way that both just almost about to touch, but they will not collide. This moves with 20 meter per second, and this also should get that 20 meter per second velocity, so that both continue to move and you can avoid the accident. Okay? Therefore, what is your V final relative velocity? I put everything in relative, so V square minus U square is 2AS. V square, that is 0, U square minus U square, 20 square is 2A, S is 10 raised to 5, or A is equal to minus 200 by This is the minimum acceleration. They ask you retardation, you have to give your plus here. They may ask in which time it takes place, you can work it out, not a big deal for you. So I hope you have understood this model. Now, suppose I am taking say this is coming with 20 meter per second, this is moving with 30 meter per second, they are approaching each other, they are likely to collide. But at one instant when the distance between them is 1000 meters, an insect started moving with 60 meter per second towards the other train. And as soon as it touches the train, it will move back. So non-stop it keeps moving. By the time the two collide, what is the distance traveled by the insect? Distance traveled by the insect. Now, this is very important. What do you mean by that? You see, first of all, what time these two trains take to collide? Let us look at that. What is the relative velocity? The relative velocity is 30 minus of minus 20. So this is 50 meter per second. SR 1000 minus 0, because somewhere they will collide. Finally 0, initially 1000, relative is 10,000. Okay, what is the time taken? S by V. So 10 raised to 3 by 50. So this is, it will take 20 seconds for these two to collide. Now he is asking distance, remember. Right? What is the distance means? How is this moving? Like that. It is continuously moving for all the 20 seconds, irrespective of the path. Therefore, the distance means the total length of the path. Therefore, distance d is equal to the speed into total time of travel, that is 1200 meters. Don't get perplexed. This is 1000 and the answer is 1200. I am looking at the repetitive distances there. Okay? Now you got it. What time it takes to collide, you got it. In 20 seconds, how far this will travel? How much? 20 into 20, 400 meters, and this is bound to be 600 meters. Okay? If somebody asks you what is the displacement of the insect, initially it is here, finally it is here, therefore its displacement is 400. If somebody asks how many trips it makes, remember I am taking it as a point mass. So, likewise, you can't count it. It becomes infinity. Unless this is finite, we can't give a specific answer. So this is an important model. I hope this is clear to you. Please do make a note of it. Okay.